Hi, all. Welcome to our first lesson, guided notes lesson. Last week, a decimals activity was posted for you, and I'm gonna say that I wasn't very happy with the amount of people that completed the work. But it's understandable. It was the first week of us being away from school, and I understand there are a lot of important things that are going on right now that has made it more difficult for us as a class to be able to complete work. So what I did this week is I'm going to go back over some of the stuff that we've been practicing, okay? And I think it might be a little bit more helpful if I am here explaining this to you, okay? So I have this guided notes activity that I'm going to post in Google Classroom. What you want to do is you want to both watch this activity and have the activity that I posted, right? Because as I'm filling this out, as I'm answering these questions, I want you to follow along with me and be able to answer those questions, right? I will like to say that I miss you guys. I wish we would be able to be doing this in the classroom, but circumstances have not allowed us to do this, so we're gonna have to do it this way. And hopefully, uh, you getting the instruction from me will be a little bit more helpful. Okay, so we're gonna begin with part one, which is a warm up, right? It's our bell ringer. I'm gonna give you about 25 seconds to answer this question. Go back to when we were in school. Parallel lines are lines that never what? All right, think about what parallel lines are and what do they never do. At least two lines that are parallel. Now, if you said the parallel lines are two lines that never touch, you would be 100% correct. All right? Parallel lines are lines that never touch. All right? So we're going to look at this map as an example. All right? So on this map, if we take a look, we have two streets that are parallel. There's actually more examples of these, but I'm going to pick the two most obvious ones. We have Ashland and we have Sheridan. Both Ashland, and Sheridan are lines that never touch, right? Ashland goes north and south, and Sheridan goes both north and south. If they keep going, right, if we extend them, Ashland and Sheridan are never going to cross each other, okay? That's what makes them parallel. So I want you to take a look at this map and take about 30 seconds to name one more set of parallel streets, meaning you're going to name two streets that are parallel. Now, I'm going to give you a hint. They don't necessarily have to be north or south. Parallel streets could also be going east and west, right? Or left and right, all right? So please take 30 seconds. Name two more streets that are parallel. I'm not going to give you the answer for this. I'm actually going to be, when you submit it, I'm actually going to be expecting you to write two streets on this map that are parallel. So the next 30 seconds is yours to fill out this part. Okay. So I hope you have filled this part out. Now we're going to move into the guided notes part, okay? So what we have here is this part. I'm going to be filling this out with you, okay? And as we go along, I will, and I expect you to also be filling this out on your document. So we're going to bring you in with a transversal. A transversal is a line that intersects two lines, okay? So on the map, I am going to show you what I mean by this, okay? I'm going to take my eraser again, my pen here again, all right? I already have circled Ashland and Sheridan. And what I want to do is I want to show you a transversal to Ashland and Sheridan. Now, it's a line that's going to intersect both Ashland and Sheridan. And one of those is Berwyn. Berwyn is the street down here, right? And if you take a look at it, Berwyn cuts across both Ashland and Sheridan. All right. So for this reason, right, we have this street, Ashland, we have Sheridan, right? And what we can see is this transversal, Berwyn, is a street that cuts those two in half. It intersects it. It doesn't cut it in half, it intersects them, right? It touches them both. So what I want you to do is I want you right now to, can you name another transversal for Sheridan and Ashland? So go back to this map and write down in this spot right here, what is another transversal? I'm going to give you 30 seconds, all right? I want you to complete this part. And as you're doing that, I'm going to be erasing these red markings. Okay, good. Now we're going to move on to the more guided notes portion, all right? Here we have some vocabulary words. Now some of these are vocabulary words that we have done in the past, okay? And some of them are going to be a little bit new, okay? So what we have here is we have vertical angles. Now we did vertical angles before we left. Vertical angles, right, are two angles that are pretty much across from each other, right? This in green here, this in blue here, this is a set of vertical angles. And what we remember is that vertical angles are congruent. Now, think about it. We did learn this, but what does congruent mean? That's right. Congruent angles are angles that are equal, right? So what that means is, if this green angle here, right, it's an obtuse angle, so if this was 120 degrees, that means that this blue angle here would also be 120 degrees, right? Now, these angles here that are not, these two angles here that are not, they don't have any type of marking, are these two vertical angles? Once again, you are correct. They are vertical angles, right? They're across from each other. So that means that they're going to be congruent angles, right? Okay, so that's a little bit practice from the past. Well, now let's move into another one that we've already learned, right? And we learned this, a linear pair, right? A linear pair, both angles A and B, and on this picture here, it shows us that A plus B equals 180, right? So angles that form a linear pair are, now this might be a new word, supplementary. Actually, it's not a new word, but let's go back because I know it's a difficult word. So supplementary angles are angles that add up to 180 degrees, okay? Now again, I understand that we have learned this in the past, but some of us forget. So it's important to understand the supplementary angles are going to add up to 180 degrees. So for instance, if angle A here was 100 degrees, that would mean that angle B here would be, again, you're on fire, it would be 80 degrees, all right? Now we're going to learn 4 new angle pair relationships that we haven't learned, all right? And we're going to understand what these relationships are. So we're going to look at same side interior angles. And what is cool about these angles is the name gives us a description of what of where they should be placed on the set of parallel lines that are cut through by a transversal, right? Lines L and M are parallel here, and this is our transversal, which we didn't give it a name. But we're going to begin with same side interior angles, all right? Same side interior angles, well, first of all, they're going to be on the same side of the transversal, right? and they're going to be interior. Interior means on the inside, right? So they're on the inside of the two parallel lines, all right? So these two angles here, right, are going to be same side interior angles. And as it's telling us, they add up to 180 degrees. So when we say the relationship between same side interior angles are, we're going to say the relationship between same side interior angles same side interior angles are supplementary. Okay. Again, just to be more specific, I'm going to put a comma here and say, which means they add up to 180 degrees. As always, I have to be making some kind of mistake when I am typing. All right, so that's same side interior angles. Now we have alternate interior angles. Okay, alternate interior angles are, let's take a look at the name. Alternate, okay, meaning that they're going to be on different sides of the transversal and they're going to be interior, okay? So if we look at our lines here, alternate meaning they're on opposite sides and they're both on interior, all right? So angle 1 and angle 2 are going to be alternate and interior, right? Let's actually take the pen so they're a little bit more clear. The angle 1 and angle 2 are alternate interior, all right? And I did a terrible job there because, I covered the numbers. But if we take a look, angle 1 and angle 2, right? This angle here and this angle here, they're alternate interior angles, all right? So what I want you to do is I want you to think about what would be my relationship there. Now, if you said that they're going to be supplementary, good thinking because you're using the words and vocabulary that we learned today, but actually that would be incorrect. They're going to be congruent, meaning that these angles are going to add up to be the same. I mean, not going to add up, they would end up being the same. They would be equal, right? So and the measure of angle 1, for instance, if that was 80 degrees, that means that the measure of angle 2 would also be 80 degrees. Okay? Now, conversely, the measures of angles 3 and 4, right, would also be congruent. So if angle 4 was 100 degrees, angle 3 here would also be 100 degrees. Okay, let's move on. We have 2 more angle pair relationships to learn, and then we're going to move on to some practice. All right, so we have a same side exterior angle. So again, this name is awesome because it's telling us where we should be looking at. We're going to be looking at the same side of the transversal, right? And they're going to be exterior. So they're going to be outside of our two parallel lines, line 1 and L1 and L2. So angle B and angle H here are highlighted in green, right? These are alternate same side exterior angles, okay? And same side exterior angles are going to be supplementary. Now, remember, that means they add up to 180 degrees. Okay?